Hey there, Ravens. We're back and we're talking about Boyle's Law, the relationship between pressure and volume. Robert Boyle did some experimenting in the 1660s. He's studying the relationship between pressure and the volume of a gas. Okay, and as he added more mercury, he noticed that the pressure over here would increase, right? So as the difference in height increased, there must be pressure increasing here to keep that height difference. All right, here's some data, and one of the things to notice here is that as the pressure, or we can look at it this way, as the volume is being decreased, as we decrease the volume, the pressure is increasing. And when you multiply pressure and volume together, you'll notice that you get a constant value. And that constant value is really referred to as the slope, or the relationship between volume and pressure. And that's a constant. So if we look at the graph, here's what the graph looks like. Okay, if you have a large pressure, there is a small volume, and with a small pressure, we get a very large volume. Okay, the graph has the shape of a half of a hyperbola. It has a negative slope to it. Okay, so here is the big deal right here. Volume and pressure are inversely proportional. Okay, if one increases, the other decreases. So this is what you wish to really get down in your notes, okay? I'm putting a big circle around it. What you have to know. I don't really care if you know that it's Boyle's Law. What I do care that you know is that as the volume is decreased, the pressure is going to increase. And that goes along with, remember when we talked earlier in a previous version, if you decrease the volume, okay, the same amount of particles when they touch the sides, okay, because pressure is when they bump into the sides of the container, same amount of particles at the same temperature, meaning they're moving at the same speed, they have less room to move, so they're going to hit the sides more often and the pressure is going to go up. Okay, and you can see that here in this picture. Okay, these whoosh lines represent the temperature. Temperature is not changing from the three samples. However, if we push the cylinder down and we increase the pressure, okay, you're going to see a decrease in the volume. And this also shows how gases can be compressed. Okay, we can push gases and get a bunch of gas into a small container because we can increase the pressure. That's why your aerosol cans say, under pressure, do not burst. All right, and there we go. Okay, and another way that we can state Boyle's Law is through this formula. If we keep the temperature and the amount of gas constant, P1 times V1 is going to equal P2 times V2. And this is the formula that you need to know. This is the formula you would use to do calculations to estimate or calculate what the pressure or the volume would be given a new set of circumstances. Okay, so we're going to look at some practice problems. All right, so pressure and volume using Boyle's Law. You're first going to read through the problem and think about it. Will the volume of the gas increase or decrease? Well, and here, let me get my pen. Okay, you have a 1.5 liters of the sample, and the pressure is 56 torr. If we change the pressure to 150 torr, that's an increase in the pressure. If pressure increases, the volume then will decrease because according to Boyle's Law, it's inversely proportional. If one goes up, the other's going down. What will the new volume of the gas be? Well, this is where we're going to use our four-step method of problem solving. First of all, write down what you know. Now, I don't have a whole lot of room on this screen, so I'm going to be writing, and I'm going to start up here. I know that the initial volume, so V1, is equal to 1.5 liters. I know that the initial pressure, P1, is equal to 56 torr. And I know that P2 is the changed in pressure, and so your final pressure is going to be 150 torr. Okay, so that's what I know. What do I need to find? I'm being asked to find what will the new volume of the gas be. So that's going to be V2, and V2 is what I'm looking for. How am I going to get there? The formula that I'm going to use Boyle's law. P1 times V1 is equal to P2 times V2. I know P1, V1, and P2. V2 is the thing I'm looking for, so I need to isolate that. All right, to isolate that variable, I'm going to get rid of the P2. Since it's multiplied, I'm going to need to divide. So divide P2, and if I do it to one side of the equation, I have to do it to the other because that's the law of math. That's the algebra law. My P2's over here are going to cancel out, leaving me with V2 all alone. So over here, so it's easier to see, I'll write my formula. V2 is equal to P1 over V1, P1 times V1 divided by P2. And now all I need to do is chug and plug and chug. So P1 is 56 torr. Okay. V1 is next, and that's 1.5 liters, and you can't see that when I go into the dark, but that's 1.5 liters. And then P2 is 150 torr. Okay, now the torrs on top and on bottom are going to cancel, and we're going to end up with 0.56 liters. Now, does it make sense? My initial volume was 1.5. My new volume is 0.56. Did my volume decrease? Yes. Was it supposed to? Yes. All good. And that one's done. Okay, I'm going to do the next practice problem in a separate video, so that'll be video number 4. Thank you.